Hello everyone, this is Miss Figueroa again. So we're looking at our second lesson in this unit in graphing polynomial functions, but today we're going to be focusing on our functions being in factored form. So our objective today is you're going to be able to graph polynomial functions from factored form. But I'm not sure if I might have to make 2 videos on this lesson because it does take a little while for me to explain everything. Alright, so first of all, we're going to be looking at different functions, even or odd functions. And so to figure out, if we look at the f of x equals x squared, is this function even or odd? So to determine that, we look at the degree of the function. So because it's a squared function that's even, 2 is even, so therefore we have f of x equals x squared is an even function. And if I want to know what does the end behavior of the function look like, because it's even, your end behavior actually ends up pointing in the same direction. When I have g of x equals x to the third, because this is x cubed and 3 is odd, then I know that g of x equals x to the third is an odd function. And odd functions, the end behavior, actually end up pointing in opposite directions. So opposite directions is an odd function. And this is going to be important later on, which is why I was going to go over it in the beginning. Alright, so then we have, for prior knowledge, if your leading coefficient is negative, what does it produce? So if we think back to our previous unit where we had like vertical stretch, vertical compression, if your a value is -1, what does it produce? So if you remember, a negative produces an x-axis reflection. So if I have a function and my a value is negative, it actually flips it across the x-axis. Alright, so if we think about those two things, even and odd and having a negative coefficient, let's see what happens. So if I have the degree is odd, so an odd function is x to the third, x to the fifth, because 1, 3, 5 are all odd numbers. And if it's positive, odd positive function, this is what my end behavior is going to look like. So if we think back to our previous lesson, as x goes to the positive infinity, that's actually talking about my right side. Y approaches positive infinity, y going positive means up. And then as x goes to negative infinity, that's talking about the left side, the y function approaches negative infinity means down. So if I look at my graph over here, I can see that my right side is pointing upwards and my left side is pointing downwards. So that's my end behavior. Then I have over here an odd negative function. So odd negative, odd meaning my degrees are odd, 1, 3, 5, and so forth. Negative meaning I have my a value is negative. I am going to produce my end behavior is going to be as x approaches positive infinity, so positive is the right side, y approaches negative means down, and as x approaches negative infinity is the left side, my y approaches positive infinity, which means it's going upwards. So if I look at my graph, I can see my right side here is going down, and my left side is actually going upwards. So this is an odd negative versus an odd positive. So what differences do you see in the end behaviors? Your end behaviors actually flip. Like on my odd positive, I have right going up, and my odd negative, the right goes down. And my odd positive, left goes down, odd negative, left goes up. So the end behaviors are actually flipped. And the reason why this happens again is because your a value is -1. And if your a value, well, not necessarily -1, but it's negative in the beginning. So that tells you there's an x-axis reflection going on, which is why your end behaviors end up flipping. Likewise, we can see a similar approach with the even functions. So if I look at the even positive, what happens? So even, remember, they're pointing in the same direction. So as x goes to positive is talking about my right side. Y goes to positive means it's going upwards. And as x approaches negative infinity is the left side, my y also approaches positive infinity, so it's going upwards. So right up, left up. So my right side here is going up, and my left side is also going up. Now if I have an even negative function, even negative tells me that as x approaches positive infinity is the right side, my y approaches negative infinity, so it's going downwards. And as x approaches negative infinity is the left side, my y approaches negative infinity is also going downwards. So in my graph, I can see the right side going down and the left side also going down. So again, what differences do you see? The end behavior is actually flipped. My right goes up, right goes down, left goes up, left goes down. The end behavior is flipped, and again, the reason why is because your leading coefficient is actually negative, and the negative reproduces an x-axis reflection. So to kind of help you memorize like even or odd, which way it goes, I like to kind of recap everything here. So my first one we have is an odd function. So odd, remember, tells you the end behavior is going to be in opposite directions. And then your leading coefficient, whether it's positive or negative, tells you which direction the right side goes specifically, okay? So the positive leading coefficient tells me that my right side is actually going to go upwards. Up because it's positive, okay? And then, again, the leading coefficient always tells you which way the right side goes. And then because this is opposite, then this tells me that the left side would then go down to negative infinity, okay? Then if I had an odd, again means opposite, but I have a negative instead of positive, negative instead of a positive, that tells me, again, it's always the right side, the right. Leading coefficient always tells you the right side. So if it's negative, the right side is going to go down, and then my left side, because it's the opposite, my left side then has to go upwards. It's the opposite of the right side. Then let's say I have an even function. So if it's even means your end behavior is going to go in the same direction. And then if it's positive, missed the V there, positive, again, the positive and negative tells you which way the right side goes. So because it's positive, the right side goes up. And because it's even, your left side has to go the same direction as your right side. So it would also go up. And then for my last one, I think I used orange. So for my last one, if it's even again means they're going to be the same direction. And if it's negative, that tells you that your right side has to go down because it's negative. And then your left side has to go the same direction as your right one, so it would also go down to negative infinity, okay? So once you have this little right, up, down, left, whatever with your arrows and stuff, then you have to translate it into your end behavior portion. So your end behavior statement is always going to be as x approaches with an arrow blank, it's going to be either positive or negative. Your function, where I think we've been using y's, but your function approaches blank, and as x approaches blank, that f of x approaches blank. So the beginning part of your end behavior as x approaches, this is going to be the right or left side. And then your function f of x, this portion of your end behavior tells you if the function is going up or down. Okay, so for example, if I were to do this here, right down, left up, my right is going to be, so think about again your x and y axis. Right side goes to positive, left goes to negative, up goes to positive, down goes to negative. So I have my right side is x approaches positive infinity, and then it's going downwards, so my f of x is going to go to negative infinity. And as x approaches the left side, left is negative, my function is also going downwards, so I'm going to go put a negative infinity here. Okay, so that's kind of how you use that for your end behavior. So we have to look at an example next. Alright, so let's look at our first example. We're going to determine the end behavior of the function. So in order to do this, first we need to determine what the degree of the function is. So my degree, I'm looking at, this is x to the what power. So I have noticed 1, 2, 3 x values, because I'm going to have 3 binomials, which tells me I have a x to the third power. So my degree here, my degree here is actually an x to the third power. So an x to the third power tells me that this is an odd function. This is an odd function, and odd means opposite. And then I need to figure out what is the leading coefficient. So my leading coefficient, my a value, is actually, and has a negative there, so that's a -1, which tells me this is a negative function. And the negative, remember, tells you which way the right side goes. So the right side tells me it's negative, goes down. And because this is opposite, this tells me that my left side is actually going to go the opposite direction of the right side, so it's going to go to the left. And then from there, I can write my end behavior. So my end behavior, I'm going to do in pink. So my end behavior, I'm just going to abbreviate as EB. I'm going to write it as x approaches. My right side is a positive infinity. The function f of x is going to approach downwards, and down is my negative infinity. And as x approaches the left side, my left side is a negative infinity. The function is going to go upwards, so my up is a positive infinity. So this is my end behavior for this specific function, and notice it was an odd negative function. Okay, so in the next example, same thing. I want to first figure out what is the degree of the function. So this is an x to the what power. Notice I have an x, and this next one has a squared. So this really means x plus 4 times x plus 4. Remember, the squared tells you there's 2 of those. So I actually have 3 total x's. I have 1 here and 2 from my binomial. So this is actually an x to the third power. And x to the third, 3 is odd. And odd tells you opposite. And then I need to figure out the my leading coefficient for my a value. Notice I don't have anything right here, so that tells me it's actually going to be a positive 1. So 1 is positive. And then positive again tells me which way my right side goes. So my right side is positive, which means it's going to go up. And then because this is an opposite, this tells me the left goes in the opposite direction of the right side, so the left would go down. So for my end behavior, I'm just going to go right as x approaches. My right side is a positive infinity. The function f of x approaches upwards is also positive infinity. And as x approaches the left side is negative infinity, the function approaches downwards, and downwards is a negative infinity. So remember my little graph thing here that I write for you guys. The right side is positive, the left is negative, the up goes positive, and then the down goes negative. So I'm just taking my right becomes positive, my up is positive, my left is negative, and my down is negative infinity. Okay? All right. Next example. Same thing. First determine the degree. So my degree here is going to be x to the what power? I have 1x here. I have a second one, and then my squared tells me I have 2 right here. So that's 1, 2, 3, 4 x's, and x to the fourth is actually even because 4 is even, which tells me then even is the same end behavior. Okay, and then I have my a value in the front. Notice it's negative, so this tells me a is -1, and that's negative, and the negative tells you which way the right side goes. So the right side, because it's negative, tells me it's going to go downwards, and because it's an even function, it's going to go in the same direction. So the left has to go the same direction as my right, and then just translate this to my end behavior statement. As x approaches my right side is positive infinity, the function approaches the down is negative infinity. As x approaches the left is negative infinity, the function approaches down is negative infinity. So that's my end behavior. Next example. These are just kind of just getting you used to the end behavior portion, okay? So first, to determine the degree of the function, I have to go figure out how many x's I have. So I have a squared tells me I have 2 here, squared tells me I have 2. So this is the x to the fourth power, which is even. 4 is even, and even means the same. And then my a value, I don't have any, like a coefficient in the front, so this tells me a is just going to be +1. I don't have a negative, so this tells me this is positive. And then positive, again, tells me which way the right side goes. So the right side, because it's positive, I'm going to go up. And then because this is even, my left has to go the same direction as my right side, so they're both going to go upwards. And then for my end behavior, as x approaches the right side is positive, the function f of x approaches upwards is positive, and as x approaches the left is negative, the function approaches upwards, so it's positive. So that is my end behavior. Okay. So let's look at some actual graphing examples. It says here, for each polynomial function, first state the end behavior, and then state the values of the real zeros, and you have to include multiplicity, and part C is to sketch the graph. So first, in order to state the end behavior, I have to do kind of what I was just doing for like the previous examples. First, I got to figure out what's my degree here. So this is going to be x to the what power? I have 1, 2, 3 x's, so x to the third. And then notice I have a negative in the front, so this is a negative here. So this tells me that this is an odd. This is 3. 3 is odd, which means opposite. And then I do have the negative, so this tells me negative means the right side is going to go down, and then the left side is actually going to go opposite, so it's going to go upwards. So for my end behavior, I'm going to say as x approaches my right side, is positive. My function is going to go downwards, is negative. And as x approaches the left is negative, the function is going to go up, is positive. So this is my part A. I stated the end behavior. Part B, now I have to go look at the real zeros. So to find the real zeros, you're going to have to make each factor equal to 0. So notice I have a negative x in the front. So I'm going to, basically what I'm doing is taking each part and I'm going to make it equal to 0. So I have this negative x over here. I'm going to make it equal to 0. And solve for x. So divide by negative 1 gives me x. 0 divided by anything is 0. Okay? So it's my part B. Then I have my next factor is x plus 3. So my x plus 3, I'm going to make that equal to 0 and solve for x. So subtract 3 gives me x is negative 3. And then for my last one I have is x minus 4. So I have x minus 4 equals 0. Add 4 to each side. Gives me x is equal to 4. So for my 3 zeros, for my part B, my 3 zeros are, and I don't know if your teachers are going to be too picky, but some teachers like to put them in least to greatest, so they might want you to write it as negative 304, but those are your 3 zeros. And then my last thing I need to do is sketch the graph. So this was from the previous lesson that I did. So you want to first draw your x and y axis. And again, I apologize for not using it like a straight line tool. I haven't figured out how to do it with this program. But anyways, so you want to draw your scales. I'm going to go like 2, 4, 6, negative 2, negative 4, negative 6, and then draw your zeros. My zeros are negative 3. Notice I didn't have any squared, so I don't have any multiplicity. So these are just going to be regular zeros. So at negative 3, at 0, and at positive 4. And then my end behavior, I have the right side going down. So next to my 4, slightly off to the right side a little bit, I'm going to draw an arrow down. And then my left side is going to go up. So next to my negative 3, shift it a little bit to the left, I'm going to draw my up arrow. And then I'm going to go connect the dots. And no multiplicity, so you're going to cross every time. So cross, cross, cross. Alright, so in our next example, you have to go practice getting the end behavior. So your degree is going to be an x to the 1 to the squared, so 2, 3. X cubed is odd, and odd means opposite. Notice I have nothing in the front, so that tells me this is positive, which means right goes up, left, then my left, because it's opposite, goes in the opposite direction. So I'm going to go write my end behavior. Okay, so go ahead and pause the video if you need to copy that end behavior, but there's my end behavior. Then I need to figure out my zeros. So for my zeros, this is part A. For my part B, to figure out the zeros, I need to go make each factor equal to 0. So I have this x minus 6 equals 0. And then solve for x is going to give me a positive 6. And then notice for my other one, I have x minus 1. So I have x minus 1 equals 0. So x is equal to 1. But this one actually has a squared. So you really have two of those. X minus 1 equals 0. So x equals 1. So notice this time for my zeros, for part B, my zeros are going to be 1 with multiplicity times 2. And then my 6 is my last 0. Okay, so now I have to go graph this. So go ahead and pause the video and practice the graphing. Okay, so don't forget your 1 has multiplicity, so I'm going to go put an asterisk to remind me I can't cross the x-axis there. And then I'm going to put a regular dot on my 6. And then I'm going to look at my end behavior. The right side is going up, so next to the 6, shift it a little bit to the right. I'm going to draw an up arrow. And then next to my 1, shift it a little bit towards the left. I'm going to draw a down arrow. And then I'm going to go connect them. So remember, asterisk means it's going to be a maximum in this case. So I'm going to go dip back down and then cross at the 6. Okay. All right. This might be my last example just for sake of time. Okay, so in this example, notice again my degree. I have to go figure it out. So I have x to the what power? I have 1, 2, 3, 4. None of them are squared, so I have an x to the 4th, which is even. And even means the same. And then I'm looking at my sign in the beginning. My sign is actually positive because I don't have a negative sign, so it means it's positive. So my right side is actually going to go up, and my left this time is going the same direction, so the left is also going to go up. So go ahead and pause the video and try writing your end behavior. All right, so hopefully you got the correct end behavior. As x approaches positive, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches positive infinity. And then for our zeros, don't forget you're making each factor equal to 0, so x plus 4 equals 0. That tells me my 0 is going to be negative 4. And then for my next one, I have x plus 2 equals 0, which tells me x equals negative 2. I apologize for my daughter in the background being loud. Okay, then I got x minus 3 equals 0, which tells me x equals positive 3. And then for my last one, I have x minus 1 equals 0, so my x is going to be a positive 1. So for my zeros, in this example, again, I don't know if your teachers want you to do it in least to greatest, but just in case, this is going to be negative 4, negative 2, 1, and then 3. Okay, so go ahead and pause the video and practice graphing this example, and then I'll show you the solution. All right, so here's the solution to the graph. None of those had multiplicity, so you should have had all of your parts of your graph crossing at the zeros because it did not produce a relative maximum or minimum. I did have another example, but I'm already at like 28 minutes, so I don't want to make the video too long. So if you do have questions, feel free to ask one of your teachers. Thank you guys for watching, and again, I apologize for the noise in the background.